In this question, we have the following scenario. We want to use cylindrical shell method and rotate this object about y-axis. Okay, what is this object, right? And let's see, I think it dropped. So you have square root of x minus 2, everything inside the radical. So let us set these to equal to each other, find the intersection first, and then try to visualize in 2D and then in 3D. Set the functions equal. We have x minus 2 equals to square root of x minus 2. To get rid of this square root, raise both sides to the second power. On the left-hand side, you get x squared minus 4x plus 4, and on the right-hand side, you have x minus 2. Bring all terms to one side, so you get a quadratic equation. Get x squared minus 5x plus 6 equal to 0. Use factorization to find x values. So it's look like we're looking for two numbers that their multiplication is 6 and the addition is negative 5. Multiplication is positive 6 and addition is negative 5. Those two numbers are negative 2 and negative 3, as easy as that. X minus 2 times x minus 3 equal to 0. So x is 2. We found the lower bound for x and we found the upper bound for x. It helps us to visualize the area between these two functions a little bit easier. Perfect. So first of all, in 2D, we have this guy, 2 and 3. So I know I'm not going to go further than 3 on the right and 2 from the left. So let us start by graphing this line, x minus 2. When x is equal to 2, you have a 0. When x is equal to 3, you have a 1, right? This is your line segment between 2 and 3. Now let us take a look at this function. If x is equal to 2, you get 0 again. When x is equal to 3, you get 1 again. But the behavior of this function is if I plug in something like 2 point, for example, if you plug in 2.5 for x, which is a number in between, you get 0.5. And here you get square root of 0.5. So what's the behavior of this object, right? It looks like it goes down here, but if the intersection of these two is at 3 and both of them are equal to 1, what's the visualization? Did we graph this correctly? This is our line, am I right? This is the piece of line that we have. But what about square root of x minus 2? Maybe we could scale it a little bit better so you have better visualization, right? Let me see if I can move this a little bit around. And okay. I need a better scaling, am I right? Or maybe I can just use this. Okay. And here we go. Just a little bit further on top. This is a very small region bounded between these two functions, and this guy is square root of x minus 2. So here we go. We are taking this object, and this guy is x minus 2 down here. so this is a 2D visualization of what we have. From this, you can find the height a little bit easy because it's the maximum y value minus the minimum y value. So this is the maximum y value, and this is the minimum y value. Find the difference between them, you get your height. But for the base, since it says, hey, you're rotating this guy about y-axis, the base is going to be located here. So if we just look at the base down here, the circumference of the base depends on your x value, right? You are moving this object. So because of symmetry, gonna have the same object to the other side, but since it's rotation, to give it a little bit of dimension, you're gonna use some dotted lines as well. So if we look at the typical shell here, the circumference of the base is 2 pi r, but r is equal to x. So this is your circumference. Let us go back to our volume formula using the shell method. This is the definite integral. My x is bounded between 2 and 3. I see it here. My x has a minimum value of 2 and maximum value of 3. This is how my x is changing. So 2 to 3. And then the circumference of the base, which is 2 pi x, times the height. And the height is the maximum y value, which is square root of x minus 2, minus the minimum y value, which is x minus 2. But make sure to put it in parentheses because you have a negative sign and you need to distribute this negative sign. So this is your circumference and this is your height. This is C and this is your H, the height of this shell or cylinder H. Very good. The rest is calculation using integration techniques that you learned before. The volume is equal to the definite integral 2 to 3 of 2 pi x times square root of x minus 2 minus x plus 2 dx. Perfect. So the volume can be calculated as the definite integral 2 to 3 2 pi x times square root of x minus 2 inside the radical minus 2 pi x squared plus 4 pi x dx. Okay, perfect. Some of the integrals are easy to work with, some others you have to use u sub. So for this guy here, we're going to use u sub because we have a quantity inside the radical. I'm going to write it down here. Let me erase this part of the board so you have enough space to see what's going on. So the integral of 2 pi x square root of x minus 2 dx, let u be x minus 2, du is equal to dx. This way, it helps us to simplify our integral a little bit easier. So this integral becomes the integral of 2 pi, but what is x? You have to write x in terms of u. U plus 2, and this guy becomes square root of u du. Dx and du are the same thing. Very good. So this integral, which is a little bit longer than usual, is the integral of 2 pi u square root of u plus 4 pi square root of u du. This guy can be written as, here you have u to power 3 halves, so you get 2 pi times 2 over 5 u to power 5 over 2 plus 4 pi and here you have a half. So you get 3 halves, 2/3, u to power 3 halves. So the integral of 2 pi x square root of x minus 2 using u sub can be calculated up here. Then I'm going to substitute that down here for you. So the volume is equal to, wherever I have u, I can switch it back to x minus 2 because u is x minus 2. So I have 4 pi divided by 5, and my u is x minus 2 to power 5 over 2 plus 8 pi divided by 3, and the u, which is x minus 2 to power 3 halves. Again, this is this guy here. Now let us write down the rest of the integrals. Minus 2 pi over 3 x cubed, which is this integral, plus pi x squared times 2. Let me make sure to write down 2 next to pi, otherwise I forget, and then plug in 2, plug in 3, and do the subtraction. Very good. So the volume is equal to 4 pi over 5. If I plug in 1, I plug in 3, I get 1 plus 8 pi over 3 times 1 minus 2 pi over 3 plus 2 pi minus, then I plug in, I'm sorry, this is just 3. So it should be 27. My bad. So we get 27 times 2 pi, and then let me write the whole thing down, plus 2 pi times 9 minus, now let us plug in 2. But when you plug in 2, these two terms disappear. You have 0 plus 0, and then plus, so you get 2 pi times 8 divided by 3 minus 2 pi times 4. Very good. So let us simplify this guy as much as we can. Oh, a lot of calculation, algebra here. Okay. So the volume is equal to, can we simplify something here? Probably. So I have 4 pi over 5 plus, so here you have 16 pi over 3, and then you have 8 pi over 3. So if I factor out 8, I get 3 pi over 3. So I have 8 pi, or 8 pi divided by 3. I get 1 plus 2, or 3 pi over 3. These two get canceled out. And then here I have 18 pi minus 8 pi plus 10 pi. And here, if I simplify this to 9, I get minus 18 pi again. Okay. Not that bad. So if I simplify this, you get 18 pi minus 18 pi, they get canceled out. So you should be getting 4 pi over 5 as the volume of this object. Ooh, a lot of algebra involved using integration techniques that you saw before. U sub that helps us to make calculation easier.